Alright, here's a video tutorial on how to graph parent functions and identify the transformations of different parent functions. So here's a quick tutorial on how to do this. First off, when we have different types of parent functions that are being transformed, the key thing is when you are trying to identify this, the first step is to identify what the parent function is. Okay, what the parent function is. The second step is to identify what has been transformed from the original. That means from the original parent function. And there are two different types of transformations that can occur. Either you have a change in the output, or it changes the x, horizontal change. Okay, this is horizontal change. Okay, and you can have, oh, sorry, not horizontal change, this is the vertical change. I apologize. Okay, but it has changed the output. And then you have what is called input, which is a horizontal change. That's horizontal change. Okay, horizontal change. Now, with vertical change, you can have a multiplier, which makes it a vertical stretch or shrink, a negative multiplier, which is a reflection over the x-axis, or you can add and subtract from f of x, or the y values, which make it go up and down. Okay. In the same way, when you have this input change or horizontal change, you can multiplier, which is a horizontal stretch or shrink. A negative, which is whenever you have a negative or an opposite, is a reflection. In this case, a reflection of the y. And when you add or subtract, you move it to the left or right. The third step, and when you're doing this, is that you want to finally sketch the graph. So we're going to go through some quick examples on how to do this process. First off, in our example number 1, the first step is we want to figure out, okay, because we want to state the transformation of the parent function. Well, first, you have to identify what the parent function is. I'll call the parent function p of x, okay? Now, in this case, a parent function can obviously be seen if you strip away all of the transformations. So if you strip away the multipliers, the negatives, and any adding and subtracting of any of the values. When you do that, for this particular function, hopefully you notice that you have the square root of x. Now, with the square root of x, this is what I call the little teapot function. It's a little teapot function because you have an initial point. You have a point of 1, 1 that passes through here, and you have it going up like so, and that is what the parent function originally looks like. Now the question is, what is happening to this parent function? Well, what I do is, once we have our parent function, check, we identify next the different transformations. And I separate them into horizontal transformations and vertical transformations. First, I'll look at the horizontal, and it doesn't matter what order you do this, but I'll just do the horizontal because I put h first. And when we do this, is that we look at the horizontal is what messes with the x. The x is what is inside, all right, the square root in this case. So we're looking at this value. And what we have is negative x. Well, the negative that is multiplied by the x, it actually stands for reflection. And because it's changing, all right, the x values, we're changing the x from negatives to positive and positive to negatives. That means it's going to be a reflection over the y-axis. So that is our first one. We have a negative that's in front of the x. Therefore, it's going to be a reflection, and it's a reflection over the y. We can then identify our next one, all right, because now we'll look at our vertical. Now, with our verticals, you see that we are adding 5. Now, this 5 is in the outside. It's outside of our parent function. It is the outputs, okay? So whatever we plug inside our input, we'll get the opposite. But what we get out, all right, what we see is that we're going to be adding 5, and also we're multiplying by 2. Now, we're going to go through an order operations here, okay, one by one, and kind of think about this logically. If I plugged in a value in for x, let's say 1, or negative 1, we'll plug in negative 1, I get out a 1. That 1, taking the square root, would be 1. And then what I would do is I would multiply that 1, if I plugged it in, or that would come out. I would multiply first by the multiplier. So the multiplier is always the first thing that's going to happen in transformation. And that 2 is actually going to be what we call a vertical stretch, because we are multiplying all the y values, all the outputs times 2. Okay? We're multiplying those by 2. It's a vertical stretch. Now, once I have that vertical stretch, I now go to the next part, is now we're going to add, because the next one is I'm adding 5. Well, if I'm adding 5 to my y's, that means the y's are my vertical. So that means I'm adding 5, which means it's going up. So I have a vertical shift up 5. So my graph, this is what would happen. This point of 1, 1. Well, first off, everything is reflected over the y-axis, so it would be over here. My value would be stretched by 2, so instead of having 1, 1, it would be 2 or 1, 2. And then what would happen is this value would then be moved up 5. So this one would be right here, but then moves up 5. So 1, 2, 3, 4, 5. This would be moved up 5. 1, 2, 3, 4, 5. I have that point there. And then this point would be moved up 5. 1, 2, 3, 4, 5. And I would have a graph that would look like this. That would be my transform graph. Because I'm shifting my points, I'm moving my points, and that would be my new function. Now we can also do, all right, this other example, okay? So we just stated transformation in this first one. Example number 2, we'll have this, then we'll finish up with this, is that I have to identify our parent function first. So what's our parent function? Well, in this one, if I take away everything, I have what is going to be x squared. Now, x squared, hopefully we realize, is going to be, all right, our touchdown function, which is this right here. All right, goes up, and probably smooth the curve right there. And that's what our parent function would be. Now, what is happening to our parent function? Well, this parent function right here, all right, is we are going to be taking, and we want to identify how we change this horizontally, how we change this vertically. Well, first the vertical change. The horizontal change. First, the horizontal change, we see that we have x plus 2. Well, with x plus 2, remember that what x value is doing to plug in, all right, to get to my original. Notice that one of my original points is 0, 0. So I always think of, okay, what do I have to plug in for x in order to get 0, back to my original value, my original point, which would be x value of 0. We'll have to plug in negative 2. So what that means is that I'm actually taking a horizontal shift to the left 2, because I have to subtract 2 to every single one of my original x values. So it's a horizontal shift to the left 2. And that appears to be my only horizontal change. My vertical changes, if you notice, is I have one on the outside, which is a negative, and I have another one, which is a negative 2 right here. Well, order operations says that whatever I plug in, I first have to multiply by the negative. So that negative means it's a reflection, just like the reflection in the previous example. Negatives mean reflections. Now, this reflection is on the outside, okay, on the outside. Unlike our previous example, all right, where we saw the negative on the inside, all right, this one is on the outside, okay? So because of that, we have a reflection where the y values will change from their opposites. So all my positives will be negatives, my negatives will be positive. So that would be a reflection over the x-axis. So that negative gives us a reflection over the x-axis. We then are going to take all our values and we're going to subtract 2 to them. All our y values subtract 2. So that would be a horizontal shift down 2. So if we were to graph this new function, we would shift it over to the left 2. So I'm going to just move this 1 point. That's the point I know. 1, 2. All right. And then I'm going to negate all these values right here. All right. So they're going to go down. And then all my points are going to be moved down 2. So I'm going to have my vertex is now going to be at negative 2, negative 2. And all my other values are going to be going reflected downward. And that is how we can transform and identify transformations of different common function parent